Hello, hello, hello. Hello. So we have another live stream today, and I'm learning about biology, biochemistry. So I'm building some small Ruby programs that can be helpful in these fields. I wanted to share that with you. Even if you're not interested in that science, we're still going to see code, so it's going to be useful. I want to explain whatever needs to be explained here. So I have this code, this Ruby, very simple Ruby script, basically program, and it's called the Punnett Square. I think it's 2 T's. So what's this? Well, it's this square. I'm going to explain it, and we're going to see the code, how this is created, right? So this is from genetics. So in genetics, we want to find out when we cross over the genes from the dad and the mother, right? We want to find out what kind of genes we the children have, right? So this is useful in genetics, for example, to find out if the child can have some kind of genetic inherited disease, right? We can find out what are the chances. One way is to use this Punnett Square, which has 2 T's, but I missed one here, and that's fine. And we're going to see the code in a moment. I just want to explain this so you have the context, right? Because this is like you're building any Ruby project. There's going to be things like this that are not related to programming, but you need to understand. That's called the domain knowledge. Domain knowledge, right? So that's the knowledge about the kind of application you're working, right? You might be working maybe in some kind of science application with your Ruby code, but for that you need to at least have some basic understanding of the domain you're working on, so you can better write your code, right? So that's called domain knowledge. If you're working on a finance app, you need to have some basic knowledge of finance terms and concepts and ideas. If you're working on a biology or genetics, you also need to have some basics of that, right? So sometimes it's not the code that's hard, but you need to understand the domain, right? There is also what's called domain experts that sometimes you will be able to have access to depending on the company or kind of group you're working with. But you still want to have this small, at least a small familiarity with the subject, with the theme, right? So that's what this is. So this represents one of the parents. It's called alleles. Each of these letters represents what's called an allele. So a gene represents a specific protein. The protein expresses a specific trait, like you can have black hair or brown hair or green eyes, right? This is a gene. A gene has 2 alleles, right? The alleles are different variations, and what's expressed is called a phenotype. What's expressed physically that you can actually see. So we have 2 alleles from one parent and 2 alleles from the other parent. So like 2 alleles from the mother, 2 from the father. And this, the square allows you to do the crossover and see the possibilities, the different results. So build this output using Ruby, and that's what we're going to look at right now. So here's the code you've probably been waiting for. And you can see it is a big mess, right? It's not production ready by any means, but it's already, at least, sorry, at least it's working, right? It's working. But we can improve this a lot because you see we have semicolons. The reason I use a semicolon is because that way I can put everything into one line. And we have another semicolon there. But you, in the ideal situation, you don't want all of this, right? You might have seen my other video in code golfing. So this is almost looking like code golf. If I start removing all of the spaces and trying to match everything like this is going to be starting to look like a code golfing program. And remember, code golfing is a programming challenge where you're trying to use the minimum amount of characters, right? It's something you can do for fun and to learn more about Ruby. But that's the opposite of what we want to do when we're writing code. Okay, so it's fine if you're just trying to figure something out and it's easier for you to just write the code as it is. You can write it like this. If it works, that's the most important thing, right? Things need to work. If it doesn't work, what's the point of writing the program? The main reason that you get paid to write code is because something needs to work and something needs to produce output. Something needs to do something useful, right? If that's not the case, then your program is useless. So that's your first priority, making things work and making things work correctly. That's why testing or different ways of testing like TDD, integration testing, manual testing, all kinds of testing. That's why testing is important as well. I have a testing course if you're interested in that. Okay, and that's separate from my Ruby book. By the way, some people have asked if they go together. No, the book and the TDD testing course are separate things, right? So there is that. Now, what can we do with this code? Well, if you find something like this, what do you do? Well, the very first thing I would like to do, and by the way, there are only 3 things you can do to improve code. Only 3 things, very simply. What are the 3 things? Number 1, you can remove something. Number 2, you can add something. And number 3, you can change something, right? So you can add, remove, or change. Only these 3 things, okay? So let's make some changes here. First, I would like to remove these semicolons, right? And this is what I'm going to do. I'm going to remove that semicolon, this other semicolon. Let's find if there is any more semicolons. Yeah, I see 2 more. Here is another. Here is another. Okay, so that's already a little bit better. Next thing I would like to look is at some formatting. Can we add spaces? Can we add indentation? Can we create blocks of similar code? Can we do some things like that? Yes, we can. For example, we can do this. That is going to separate our method calls. So now we can already see, oh, we have cars, we have product, we have map. Now these methods become a lot more apparent. They stand out more. So it's easy to find out what's going on, right? So let's keep doing that. We have map, we have then, which is a very interesting method. If you're not familiar with then. These are recent methods. So if you have an old version of Ruby, then you won't have the then method. But I really like it. It's very helpful. And whenever I have to work with older version of Ruby, I miss it because it's very helpful. I have a video about this if you don't know what this is. But by the way, it is from Ruby 2.6 minimum, right? So there is that. Okay, let's keep doing that. Join. So I'm looking for the method calls. Method calls require this dot. Usually there is other ways to do a method call, but it also involves a dot. Usually it's like dot send. This dot means we are sending, so the more technical language is we are sending a message. So we are telling the object to do something. That's called, in a technical object-oriented programming world, is called sending a message, right? Maybe you read that if you read a lot about object-oriented programming. A lot of people will say, oh, we're not calling methods. We're not calling methods. We're sending messages. Okay, whatever. Yeah, and kind of changes the way you can think about it if you stop to think more deeply about objects. But in your day-to-day, maybe it doesn't matter that much. Maybe you might disagree. That's fine. So sending messages is the more technical terms for calling a method. Why? Because we're telling the object A that we want the characters. We're telling, oh, the message characters. Well, but how we actually implement that is using methods, like, right? We say def cars, whatever. Methods. So yeah, let's use a little side information that you might find interesting. So yeah, we have our method calls. We start with this dot, the name, and sometimes we have parameters like this and this, and sometimes we have blocks. If you don't know blocks, it is very important to know blocks, because blocks are major part of Ruby. If you don't know blocks, you shouldn't even be looking into anything else. It's that basic and that important. Okay, so blocks are basic part of Ruby, and as you can see, this demonstrates the different kinds of method calls. No, without arguments, with arguments, and you will also notice the parentheses are optional. So you can see here I have no parentheses. Here I have parentheses. Usually I would recommend to keep consistency. So let's do that. Let's keep consistency. And that means if I use parentheses here, I want to use parentheses here, right? In both places. So when another person comes, doesn't ask, oh, why does this one use parentheses, this doesn't? Is there any meaning behind that? No, you don't want people to waste time like that. Just be consistent. So more easily we can identify what's going on. And then we have the blocks with their own parameters, in this case G. Okay, so that's what's going on in here. You can see only with these very little changes. I didn't do any massive design. I didn't pull out some kind of design, software design program, or I didn't pull out a whiteboard, or I didn't do anything of that, any of that. I didn't have to come up with a big group of expert developers to figure out this design. I did very simple changes just to get at least 10x better code. Why? Because we can more easily see what's going on. We can see, okay, this chain of methods. We can see the individual methods without having to put a lot of effort trying to find the methods. And we can get a better general idea what's happening here. Okay? Yeah, so what else could we make here? What differences? Well, we have this twice. We could consider making this into a constant, something like that. Also, we have this line which looks a little bit like a mess, so we can look into that. So let's give this a try. We can try. Oh, by the way, before we continue going, let me run the program again and confirm that it's still working. Because one thing that will happen, I don't have test for this particular program, but if I had test, I would be running the test every time I make a change. Why? Why do you think I would do that? Well, because every time you make a change, you are in the risk, you run the risk of breaking the program, meaning the program will stop working correctly. And one way to make sure that it doesn't stop working correctly is to have test. And if you don't have test, then what you have to do is do manual testing, which is slow. But because this is a very simple program, I'm not going to deploy it to production or anything, just for personal use. Then I don't really have test. But so that we can quickly see the manual test, which is in this case is compare the output this with this. There is one kind of testing which is exactly this, but automated. It's called, well, it has different names. It's called like golden master testing, acceptance testing. It has a few different names depending on who you ask or what website you read. But basically the idea is you dump out the output like this. Here's a trick to do that. So trick coming up for you. I think this also works on Windows, but I'm not 100% sure. What you can do is you can dump the output. So that means we can save the output into a file. So we can say punnett.txt and yes, this to this, and that will save the output into a file. And now what we can do is we can diff. You can find the difference. So there is a program called diff in Linux, and with this you can find out the differences. Let's see if I remember. We take compare files side by side. Well, it has a lot of options, as you can see. You could take the output from your Ruby program. I think we can do something like this. I'm not quite sure, but let's find out. And then we can do like cat. So cat will print out the contents of our file. Oh, I think there is an option to compare like the actual data, contents of line. Let's see, as text. To file, from file, exclude file, new file, paginate, side by side, no, output, report, output, files. But I want to compare like actual. I think there is an option. Cursive. Maybe this. Basically, what I'm looking for is this will print the output of the program, and this will be the output of the program. I think we can pass. Maybe we can pass the output into diff. I think we can, hold on, I'm going to log this up really quickly. Div compare output of programs without temporary files. Yeah. I'm looking on another screen for... Oh, that's interesting. Apparently, we can do this. So there is no difference. Now let's say that come here and these changes. Ta-da! Now it tells us that it changed, right? Or maybe these changes. There we go. See? That's one way you can do this. That's like a kind of testing. Okay, I'm going to take a quick look at chat. Let's see if we have someone. We have Omar Terrazas says, hello Jesus, hello Omar, how are you? And we have another name that I'm sorry I can't pronounce because it has like strange characters that I don't understand from another language. He says, hi. Well, hey to you, I hope you're doing great today. So we have that, and that will be my initial refactoring. We could do more refactoring here and there. Maybe something with this, because I see a lot of repetition with these things. See this and that. Not a big fan of these things being repeated like that. Maybe we could use a join. So maybe we can do this and comma that, comma this, and then we put this into a sub array. By the way, it's really hot right here, so I need to open my door. I don't have an AC or anything like that, so we can do join, and then we can join with this. See, that might work. Let's find out. Does this seem to work? We get an error. Define method join. Well, of course, because I'm joining on the wrong place. Does that make sense? That doesn't quite work. There's an extra space there. Yeah. That works. But is this better? Well, that's the question. I don't know, because I still don't know what B0 is supposed to be, or G0. Well, G is one we are mapping over. Let's see. Maybe if we did like this, it would be a little better. No. I think I'm just going to leave it like this. Okay. Oh yeah. It is already proving to be pretty helpful. That's a nice command for you to write down in your notes. So basically, this a file with the original output. This is the file. This is the output of our current program. Right? And here inside this, you can put anything, any two programs that you want to compare, and find out the differences. That's what diff is. By the way, it is like a default program that comes with Linux. It's almost default, I believe. So what else? Well, the fact that didn't work, this probably means we have a missing data structure here, right? When this happens, maybe we're missing something. We're missing like a new class, a new kind of object, and that could be something like a struct. You can make a struct. Maybe we want a gene struct, gene, something like that, and maybe we want something else. So the B here represents the second gene, so this one, and the G is going to be our crossover of genes. Okay. So I'm getting this and this. This and so this and this and this. So maybe we can solve this with something like first and second, or left little right a little. We could solve it like this, maybe. And maybe we can do gen.new, gen, this is going to be left cars. I think can do that. Let's find out. Maybe get a big fat syntax error. And undefined method cars. Yeah. Well, I guess that worked. So that's good. So that means that we can take our gene A, gene B. And here, instead of doing all of this stuff, you can probably just map over, let's see, this is going to be something like gene A. I'm trying to translate this into our new data structure. So that's going to be like gene B, left allele, gene A, right, left allele, with gene B, left allele. So it's all the left, isn't that right? It's going to be this crossover with this and this. I think we can do that. and then we can join them with that thing. So we can do like row, this is going to be this, row 1 and row 2, and this is going to be crossover of the right allele. Is that right? Let's find out. So we're going to have row and row 2. Define local variable method A. Yeah, because we don't have A anymore. We just have this. Where is A being used? Oh, there. Is this going to be like this? Yeah, this is this. Hold on. This is this, and this is that. Okay, now this is going to be interesting. We're printing the and the, which is so we want, let's see what's the original. Original, we're supposed to print this. And here's where diff is not that helpful, because it's harder to see the differences. So I'm just going to print the two things, compare them directly. So this dd, oh, we're missing one of the alleles here. Right, okay. So we have the first one, which is the leading one. This is correct. Then we have the next one. Yeah, because these two of them. Because before we had them crossover, we had the crossovers right here. So it was left plus left. We had all of the crossovers done differently with the products. So left plus left, left plus right. Left plus right. No, let's see. Right. Left plus left. So that's the, no, this should be t plus t, and then t plus t. Yeah, that's about t. So that's left plus right. But for some reason that's not working. Oh, because that's interesting. It's be right plus left. Okay. And then the second row should be, yeah, it is getting a bit more complicated because we are coming up with the actual combinations. In that sense, it's more complex. Right allele, and then pretty much do this, and then we're going to replace this. Okay. I think we can do right plus right and left plus right. Syntax looks, yeah, that's it. So this is a completely different approach. See what happens. I created this structure and this changed completely the approach we took to solve the problem, right? And here we could probably do this, and 2, 3, 4, this. And that's working. Probably do that. Gen A. And this. No, that's not necessary. And we can replace that with separator or line or dashes maybe that. Yeah, so we ended up with a completely different looking program. Notice that the only thing I changed here, yes, this took more work, but went up with something very different. Now, is this better? Well, better or worse depends on a lot of things, right? We can look, we have, is it easier to understand? Is it easier to change? Is it easier to read? If you come back 1 year from now, which version of the code would you rather have? Right? Things like that, questions you can ask. Do we have less complexity or less complexity? We have more loops or less loops? Do we have more method calls or less method calls? Do we have more if statements or less if statements? And by the way, less if statements and less loops is almost always better, right? Less complexity. In fact, one metric, one way to measure complexity is less if statements. So that's one way to do it. And one thing that become very clear here that was implicit before, and implicit means it's not there, it's happening, but it's hidden, right? It's something that's in there, but you don't see because it's kind of hidden. You have to really figure it out. That's what implicit means. Explicit means it's implying sight. You can clearly see it. What I'm talking about the different combinations that are happening. So in here it's very clear that our first round is formed of left allele plus left allele. So that means this D plus this D here. And the second part of the square means is our right allele plus our left allele. So that's this plus this one. So notice it's explicit, it's clear what combinations are we using, where it was kind of not clear before because I was using a method called product, and this method we combine two arrays for you. It does these combinations, but you don't see the actual combination directly. So if you can make something explicit and it's helpful to have this information, then that could be considered better, right? So there is that. Okay, so what do you think? Do you have any comments, any questions, any feedback? I will be happy to hear that from you. Type them in the chat or the comments if you're watching this as a recording. By the way, if you're new here, this Jesus Castillo from rubyguides.com. Okay, we have over 150 articles on the website. We have a newsletter where it's just me running this. I'm not going to pretend it's a big company with many people. It's just me running the show. I don't even have an assistant or anything. It's just me. So I have all of this content on the website for you. Have the book. I have also a TDD course, a testing course, which is separate from the book. I even have a Postgres book, which I wrote a few years ago. If you're really interested in that, let me know. I also have something very little people know, have a Rails course that I have never released because it's hard to get Rails right, the teaching of Rails, because it's very complex. There are a lot of pieces. So I haven't really, I'm not completely, I don't know how to explain it, but I'm not completely sure about that course. Maybe because, I got 2 people to go through it, and I got a lot of improvements. But I'm not sure what else can I add to make Rails easy to understand. I have quizzes, and I have a lot of things. You can even get a certificate, auto-generate certificate at the end. You can keep track of your progress. So I think all of that are really good things. I read a lot of learning techniques. So maybe one day I will release it and see how that goes. So that's another thing. And of course, I also have this YouTube channel where I have over 100 videos where you can learn also Rails, Ruby. And by the way, if you are new to Rails, one thing that a lot of people get confused is Ruby on Rails is not a language. Ruby is a language. Ruby on Rails is a tool. It's called a framework, a set of tools built on top of the Ruby programming language, right? So you want to start learning the programming language, learn the basic concepts of programming like loops, if, conditionals, unless, learn about methods, learn about strings, arrays, hashes, and all of these basic things, variables, constants, which is a kind of variable. You want to learn that if you don't want to get super confused when you get into Rails. Because I've seen people that go into Rails and they don't know what they are doing, and that doesn't turn out very good. And when you go to an interview, usually they give you a Ruby only. So that's a Ruby like programming challenge. And if you do well there, you're going to stand out a lot, because most people waste their time not understanding the basics. Okay, so there is that, and you can do that using all of my resources. Okay, we have Yasin Kerim. Hi Jesus, you should develop clone project from Turkey apparently. Well, welcome, and thanks for your suggestion. And we have Burak Kaimaki. What are you doing? Well, I'm working on this little refactoring project we are just finished, so you can see here. So this was a project, it's something called This from Biology, more specifically genetics. It's called the Punnett Square. It's 2 T's, but I only have one in the name of the file, because I found out there's 2 T's later and I didn't want to rename it. Well, it was very messy to start. You can watch the recording. It was a whole mess, everything in one line, semicolons, and a big mess. And you see, I think turned out pretty nicely here. I use the key change here that I used to create a specific structure to represent the data, right? I use a struct because in this case I don't need methods. I just need to manage the data. So variables can be by themselves are usually insufficient. You need data structures. You need ways to manage your data. One way to do that is to create objects. One kind of object you can create is called a struct, which is part of Ruby, right? This has nothing to do with Rails. This is core Ruby. And of course, Rails adds methods, has its own things, but you first need to master your basics. So there is that. If there are no more questions, well, thanks a lot for watching, and I will see you in another video.